Welcome to the Slop Temple. We pray this video helps.
You begin by wiring the sensor to an interrupt-capable digital pin and powering it correctly. Make sure grounds match. Once connected, mount a magnet or reflective mark on the rotating shaft so 1 pulse equals 1 revolution. Now open the Arduino IDE and start a sketch. Declare a volatile counter and an ISR that increments on each falling or rising edge. Upload a minimal loop that prints counts to serial, so you have real-time feedback while you move to measurement logic. You now add timing and convert pulses into RPM. Choose millis for simplicity or micros for higher resolution. Measure counts during a fixed interval such as 1 second. Once the interval elapses, disable interrupts briefly, copy and reset the volatile count, then compute RPM as counts divided by interval seconds, times 60. To improve accuracy, implement simple debounce or require minimum time between pulses and average several intervals. Finally, print RPM and optionally send filter. You finish by presenting RPM on your chosen output and validating readings against a reference tachometer or a motor with known speed. Once done, adjust sample interval or averaging to balance responsiveness and stability. Shorter intervals are responsive but noisier, longer ones are smoother. If values jump or skip, make sure the magnet or reflective mark is secure, sensor alignment is stable, and wiring is shielded. As a key troubleshooting tip, verify interrupts are on the correct pin and add debounce or a small hardware capacitor if spurious pulses persist.
Thanks for watching. Consider subscribing if we helped you.